Okay, we are going to start with the new chapter, and the chapter's name is Semiconductor, which is your chapter number 14 in your textbook. Therefore, I want all of you to write the main heading, chapter 14, Semiconductors. Write only that much and then you stop. Write only that much and then you stop. The name of the chapter is Semiconductors, chapter number 14. Okay. Now, 1 minute. Okay, now listen. Based on electrical conductivity, means how well a solid can conduct. What electricity? How well a solid can conduct electricity. Based on that, solids are classified into 3 categories. Listen to me carefully. Based on how well a solid can conduct electricity, they are divided into 3 categories. Which are the 3 categories? Conductors, semiconductors, and insulators. Conductors, semiconductors, and insulators. You might all have studied this in your high school also. What are conductors? What are semiconductors? What are insulators? So can I say conductors are something which conducts 100% electricity? What are conductors? Conductors are something which conducts 100% electricity. What are insulators? Insulators are something that conduct 0% electricity, means they do not conduct electricity at all. Conductors conduct 100% electricity. Insulators conduct 0% electricity. And semiconductors conduct electricity between 0 and 100%. Okay, so I'll repeat. If anything conducts 100%, it is called conductor, 100% electricity. If anything does not conduct at all, 0%, then it is an insulator. And anything that conducts in between, that is between 0 and 100, then it is called a semiconductor. Now tell me, what is responsible for electricity, or who is responsible for electricity? Can anyone answer? Who is responsible for electricity or conduction of electricity?
Free electrons.
Free electrons, correct. Not only electrons, can I say free electrons? Free electrons are responsible for conduction of electricity. Therefore, can I say a conductor will have lot of free electrons? Because only if you have lot of free electrons, you can conduct 100% electricity. Can I say insulator will have 0 free electrons? Because insulator will not have any free electrons. That means insulators cannot conduct electricity. And semiconductors will have free electrons between insulator and conductor. Means not as many as conductor, but not 0 as insulator also. Now, what is responsible for conduction of electricity is free electrons. Only if the electron is free, it can conduct electricity. Correct. Therefore, can I say conductors will have large number of free electrons? Insulators will not have any free electrons, and semiconductors will have free electrons between conductor and semiconductor. Okay. Now, how much percentage conductor will conduct? 100%. How much percentage insulator will conduct? 0%. And how much percentage semiconductor will conduct? Between 0 and 100%. Now, what is the best example of conductor? Tell me, what is the best example of conductor? Best examples of conductors. Can I say all metals are best examples of conductors?
Yes.
All metals are best examples of conductors. Insulators, the best example of insulator is rubber, plastic, glass, and all that. And tell me the best example of semiconductor, or tell me the 2 best examples of semiconductor. Tell me the 2 best examples of semiconductor. The two best examples of semiconductors are germanium and silicon. The two best examples of semiconductors are germanium and silicon. So I'll give you the basic definition. You write down and then I'll give you the actual definition. Okay. So everyone has written the main heading semiconductors. Below that, write down start writing the notes. Based on electrical conductivity, solids are classified into based on electrical conductivity, solids are, yes, Ruchit, correct. Based on electrical conductivity, solids are classified into three groups. Based on electrical conductivity, solids are classified into three groups. First one, conductors. Second one, semiconductors. And third one, insulators. Based on electrical conductivity, solids are classified into three groups. First one, conductors. Second one, semiconductors. Or second one, you write insulators. And third one, you write semiconductors. First one, conductors. Second one, insulators. And third one, semiconductors. Okay. Based on electrical conductivity, solids are classified into three groups: conductors, semiconductors, insulators, and semiconductors. Now write down the side heading conductors. Write down the side heading conductors. Write down. Conductors have large number of free electrons. Conductors have large number of free electrons. Conductors have large number of free electrons, due to which electricity can be conducted. Conductors have large number of free electrons, due to which electricity can be conducted. Conductors have large number of free electrons, due to which electricity can be conducted. Full stop. Examples. Example, metals. Below that, write down example. Example is metals. Example is metals. Below that, write down one more side heading, insulators. Write down the side heading, insulators. Write down the side heading, insulators. Write down, insulators have no free electrons. Insulators have no free electrons. Insulators have no free electrons. Insulators have no free electrons, due to which no electricity can be conducted. Insulators have no free electrons, due to which no electricity can be conducted. Insulators have no free electrons, due to which no electricity can be conducted. Now, example of insulators will be, write down example, glass, rubber, plastic, wood, glass, glass, rubber, wood, plastic. Next side heading, semiconductors. Next side heading, semiconductors. Next side heading, semiconductors. Below that, write down the conductivity of semiconductor. The conductivity of semiconductor. The conductivity of semiconductor the conductivity of semiconductor lies in between the conductivity of semiconductor lies in between that of the conductivity of semiconductor lies in between that of conductor and insulator. The conductivity of semiconductor lies in between that of the conductivity of semiconductor lies in between that of conductor and insulator. Lies in between that of conductor and insulator. Example. Now, best example of semiconductor is germanium and silicon. The best example of semiconductor is germanium and silicon. Yes, sir.
Sir, can you repeat definition of semiconductors?
The conductivity of semiconductor lies in between that of conductor and insulator. The conductivity of semiconductor lies in between that of conductor and insulator. Okay. Clear? Okay.
Sir,
Yes.
सर वन डाउट कि कंडक्टर के पास फ्री इलेक्ट्रॉन्स होते, सेमीकंडक्टर के पास फ्री इलेक्ट्रॉन्स होते क्या नहीं होते?
Conductors will have large number of free electrons. Semiconductors will have little bit of free electrons, and insulators will not have any free electrons. Okay. Anyway, I'm going to explain that topic in detail now. What is free electron and all that. Okay. Conductors will have large number of free electron. Insulator will not have any free electron, and semiconductor will have few free electrons, some free electrons. Okay. Now, how it happens and what happens, that I'll explain in the actual topic. Okay. So this is the basic definition of conductor, semiconductor, and insulator. Basic definition means your high school definition. So did you understand the definition what you have written? This is your high school definition. Means conductor is very good conductor. Insulator is not at all conducting. Semiconductor is conducting between that of conductor and insulator. This much is clear. Now, first let me tell you small things so that your chapter becomes easier. Tell me what is the unit of energy? Anyone, what is the unit of energy?
Joule.
What? Joule, correct? Unit of energy is joule. But in this chapter or in electronics, in general electronics, we take the unit of energy as electron volt. Means it is a unit, but it is not an SI unit, but it is a very small unit. Don't write, just listen to me. Therefore, I take the unit of energy in the whole chapter. Means in my whole chapter, I will take the unit of energy as electron volt itself. Okay, not joule. Joule is the SI unit, correct? But my energy is so small. That means throughout my chapter, I will measure my energy in terms of electron volt. And 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Okay, that is nothing but charge of an electron. Therefore, you should know the conversion between 1 electron volt and 1 joule. How is this pronounced as? It is pronounced as 1 electron volt, 1 EV. Therefore, in this chapter, all my energy will be measured in EV, that is electron volt. In my chapter, that is semiconductor, all the energy will be measured in this unit, that is EV, which is electron volt. Clear? And 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Make a note. Even electron volt is a unit of energy. Even joule is a unit of energy. But in this chapter, I will measure all my energy in terms of electron volt. Correct? Okay. Therefore, the next thing that you need to write is 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Written? Okay? Okay, good. Now, one more thing. See here, this is a nucleus of an atom. This is the first orbital. This is the second orbital. This is the third orbital. Like that, fourth, fifth, sixth. Tell me, what is the last orbital or what is the last shell called of an atom? Tell me. What is the correct? The last shell is called as valence shell or it is called as valence band. Okay. Now tell me, if the electron is in the valence band, that is the last band of the atom, is the electron free or not free? Please reply. If the electron is in the last band of an atom, whether the electron is free or not free. In other words,
it depends on the number of electrons.
I cannot hear it.
Sir, it depends on the number of electrons.
Your voice is very, very low.
Sir, it depends on the number of electrons.
No, it does not depend on number of electrons. Imagine there is only one electron, okay? Over here. Tell me whether this electron, whether it is free or
Sir,
not
it is
free.
free.
Not free.
Free, simple question. Free or not?
Not free.
Why?
Because still it is a part of the atom.
It is still a part of the atom. Therefore, can I say this electron, which is in the valence band, is still not called a free electron? What is a free electron? Free electron is an electron which is not a part of any atom. It is not bounded to an atom. It is free. Please listen to me carefully. Very important concept. What is a free electron? Free electron is an electron which is free. That means it is not bounded to any atom or it is not a part of any atom. It is free. But can I say an electron in the valence band? Can I say an electron in the valence band is not free? Because can I say electron in the valence band is still bound to the nucleus or it is still a part of the atom? So my simple question to you is, Will electron in the valence band conduct electricity? Will electron in the valence band conduct electricity? Yes or no?
No.
Answer is no. Correct. Answer is no. You know why? Because only free electrons conduct electricity. Only free electrons conduct electricity. Therefore, electron in the valence band is not free. Therefore, electron in the valence band will not conduct electricity. For the electron to conduct electricity, everyone listen to me clearly. This electron will have to jump from this band outside. Then can I say if the electron comes here, everyone look at the screen. Can I say if the electron comes here, then can I say it is free? Because now it is no longer a part of any atom. If electron jumps out of the valence band, can I say it is free? Now, outside the atom, the complete space is called as conduction band. Outside the valence band, the entire space is called conduction band. Therefore, can I say only when the electron is in conduction band, only when the electron is in conduction band, it will conduct electricity. And as soon as or as it is in the valence band, it will not conduct electricity. Therefore, for an electron to conduct electricity, it should be in the conduction band. For electron to conduct electricity, it should be in the conduction band. It cannot be in the valence band because valence band is still a part of the atom. Is it clear? Okay, now let me draw one more diagram and explain. Now I have nucleus, I have first orbital, second orbital, and the last one is called as valence band. And the last one is called as valence band. And electron over here, okay, is still not free. Electron over here is still not free. Now, only when the electron jumps from the valence band into the conduction band, then I can say electron is free. 1 minute. Only when the electron jumps from valence band to the conduction band, only when the electron jumps from valence band to the conduction band, can I say it is free? Therefore, electron in the valence band is not free. Electron in the conduction band is free. Is it clear? Tell me yes or no. Is it clear? Now, what is conduction band? Conduction band is anything outside valence band is conduction band because outside valence band electron is free. So can I say if you go outside your house, listen to me, if you go outside your house, you are free. As long as you are inside your house, you are not free. As soon as you go outside your house, you are free. Now, outside your house can be Pune also. It can be Nagpur also. It can be Goa also. It can be USA also. Anywhere outside your house is free. Therefore, anywhere outside your house is conduction band. Doesn't matter where, but outside your house is conduction band. That means this whole area will be conduction band. Anywhere it can go. Okay. Therefore, can I say if I want a solid to conduct, electricity, all the electrons have to jump from valence band to conduction band. If I want the solid to conduct electricity, if I want all electrons to conduct, can I say all the electrons have to go from which band to which band? If I want all electrons to
valence band to conductor band.
conduction band. Now, this is the logic. Okay, now this is the logic. We will only be dealing with valence band and conduction band, and all my definitions will be related to valence band and conduction band. Now, the definition is very, very simple. Okay, now See here. Okay, everyone see here. Some of you who have attended JEE class might already know this diagram, but everyone listen to me. Everyone listen to me. Take a conductor. Okay, now take a conductor. So listen to this. In a conductor, see, this is my valence band. Everyone look at the screen. This is my valence band, and this is my conduction band. Now, in my conductor, my valence band and my conduction band are overlapping. What is happening? Repeat in your mind. In my conductor, my valence band and my conduction band are overlapping. What is the advantage? Listen. Therefore, any electron in the valence band can easily go to the conduction band because there is no gap. Therefore, can I say, see here, please look at this. Please look at this. This is my conduction band. This is my valence band. Okay, now electron is in the valence band. Say maybe there are 3 electrons in the valence band. Now, can I say if the gap between valence band and conduction band is more, gap is more, then can I say electrons might not be able to jump to conduction band? But if the gap is 0, if the gap is 0 means how? Listen to this. This is my conduction band and this is my valence band. Can I say in this case, my valence band and my conduction band are overlapping? Now, what happens when your valence band and your conduction band overlap? Can I say electrons can easily travel from valence band to conduction band because there is no gap? You can easily travel. Therefore, can I say all the electrons can travel from valence band to conduction band? And if all the electrons travel from valence band to conduction band, all electrons will become free. And if all electrons become free, they will start conducting. That is why this is called as a conductor. Therefore, till now, what definition you have written about your conductor is your high school definition. From today, if I ask you what is the definition of conductor, listen to the definition clearly. Conductor is a solid in which valence band and conduction band overlap, or the energy gap or the gap is 0 electron volt. The gap between valence band and conduction band is 0 electron volt. That means, I'll repeat, define a conductor. Your answer should be conductor is a solid in which the energy gap between valence band and conduction band is 0 electron volt. Now, since there is no gap between valence band and conduction band, since there is no gap between valence band and conduction band, electrons can easily travel from valence band to conduction band. And what happens when electrons can easily travel? All the electrons will become free, because as soon as electron reaches conduction band, they are free and they are free to conduct. Okay. Therefore, I want you to write down the side heading, band theory of solids. Write on the side heading, band theory of solids. Switch on your cam, all of you. Write on the side heading, band theory of solids. Write on the side heading, band theory of solids. Band theory of solids. Below that, write down conductors. Below that, write down conductors. Okay, and below conductors, write down. Below conductors, write down. Conductors are solids in which. Below conductors, you write down. Conductors are solids in which. Conductors are solids in which. Conductors are solids in which the energy gap between. Conductors are solids in which the energy gap between valence band and conduction band. Conductors are solids in which energy gap between valence band and conduction band is 0 electron volt. Conductors are the solids in which energy gap between valence band and conduction band. Conductors are the solids in which band gap between valence band and conduction band is 0 electron volt. How do you write 0 electron volt? Look at the screen. 0 electron volt. The band gap between valence band and conduction band is 0 electron volt. Okay. Written? Okay. Now, below that, draw the diagram of conductor. Right now, draw the diagram of conductor, which I have shown on the screen. Okay, draw it properly. I will show you the marking. This is valence band. And this will be conduction band. And they are overlapping. Please remember, conduction band always comes above valence band. Okay, don't make that mistake. Conduction band always comes above valence band. Written? Okay, I'll give you one more minute. Write it neatly. Make sure you mark the axis as energy. Got it? Okay, now listen. Next one. Okay, now listen to the next one. Semiconductors. Now listen to me carefully. In conductors, look at my hand. Valence band and conduction band overlap. So electrons can easily go from one band to the other band. Now in semiconductors, the band gap is little less. Can you see the diagram? Can I say they are not zero? Can I say the band gap is there, but it's very small band gap? So what will happen is, if there are 3 to 4 electrons, since there is a small gap, some electrons can jump, some electrons cannot jump. Now tell me, if some electrons can jump, some electrons cannot jump, then can I say what? It is not 100% conductor. Correct, it is not 100% conductor, because what is the definition of conductor? 100% conduction. It is not insulator also, because what is insulator? Insulator is 0%. Therefore, can I say, if the gap is very small, Very small means mathematically lesser than 3 electron volt. Few of the electrons can jump from valence band to conduction band. Not all, few. Therefore, then can I say it is like a semiconductor, not conductor, not insulator also. Insulator would be no electrons can jump. But here some electrons are jumping. Therefore, can I say this is the definition of semiconductor? So can anyone tell me the definition of semiconductor? Looking at the definition of conductor, it is the same, only one word is different. Look at the definition and tell me. What is the definition of a conductor? Conductor is a solid in which energy gap between valence band and conduction band is 0 electron volt. Now, can you tell me how will I change it for semiconductor? Listen to me.
Less than
It will be 3
3
electron.
electron volt.
Less than 3 electron
Less than
volt.
3.
Semiconductor is a solid. Listen to me. Semiconductor is a solid in which energy gap between valence band and conduction band is less than 3 electron volt. Instead of equal to 0 electron volt, you just have to change. Please look at the screen. Instead of writing equal to 0 electron volt, you just have to change and write lesser than 3 electron volt. That's it. You just have to write lesser than 3 electron volt. Is it clear? Make a note, write down. Side heading semiconductor, write down side heading semiconductor. In that, write down the definition. Semiconductor is a solid, write down the definition. Semiconductor is a solid. Semiconductor is a solid. Same thing like conductor, in which the band gap between semiconductor is a solid in which band gap between semiconductor is a solid in which band gap between valence band and conduction band. Semiconductor is a solid in which band gap between valence band and conduction band is less than 3 electron volt. Semiconductor is a solid in which band gap between valence band and conduction band, the band gap between valence band and conduction band is less than 3 electron volt. Written, band gap between valence band and conduction band is less than 3 electron volt. Clear? Okay. Draw the diagram below the definition. Draw the diagram quickly about a semiconductor. Start. Draw the diagram. I'll be back in 2. In the meantime, finish the diagram. Switch on your cam. Next side heading, insulators. Right on. Next side heading, insulators. Now look at the diagram. Okay, look at the diagram for insulator. Now, can I say the gap is very large? Can I say the gap between valence band and conduction band is very, very large? Now, if the gap between valence band and conduction band is very, very large, tell me what will happen. If the
Electrons
gap,
cannot travel.
electrons cannot jump at all from valence band to conduction band. So can I say the electrons which are in the valence band, since the electrons are in the valence band, and the gap between valence band and conduction band is very, very large, can I say electrons cannot jump at all because the gap is too large? Therefore, this is energy gap is greater than 3 electron volt. Energy gap is greater than 3 electron volt. Now, can you give me the definition of insulator looking at the previous definitions of conductor and semiconductor? Can you give me the
Yes, sir.
definition of
Insulators are the solids in which the energy gap between valence band and conduction band is more than 3 electron volt.
correct? Same thing. Instead of lesser than 3 electron volt, I just need to replace the definition with greater than 3 electron volt. I just need to replace that with greater than 3 electron volt, correct? Therefore, write down. Side heading, insulators. Below that, write down. Insulators are the solids in which insulators are the solids in which insulators are the solids in which energy gap between insulators are the solids in which the band gap or the energy gap between valence band and conduction band. Insulators are the solids in which energy gap between valence band and conduction band. Insulators are the solids in which energy gap between valence band and conduction band is greater than 3 electron volt. Okay, the band gap between valence band and conduction band is greater than 3 electron volt. It is greater than 3 electron volt. Clear? The energy gap between valence band and conduction band is greater than 3 electron volt. Written?
Yes, sir.
And below that, draw this diagram. Done? Now, look at the screen. Now, can I say okay? Now tell me, what is the energy gap? Eg means energy gap. What is the energy gap of a conductor? Can I say it is 0 electron volt? What is energy gap of a semiconductor? Can I say
Less
it
than
is
3.
lesser than 3 electron volt? And what is the energy gap of an insulator? Greater than 3 electron volt. Correct? Therefore, can I say the energy gap of a conductor is 0 electron volt? Energy gap of a semiconductor is lesser than 3 electron volt, and energy gap of an insulator is greater than 3 electron volt. Clear? So listen to me. If there are 5 electrons in the valence band, please listen to me. If 0 electrons can jump to conduction band out of 5, tell me which kind of solid it is.
Insulator.
It is an insulator. Out of 5 electrons in the valence band, if none of them can jump to the conduction band, then can I say it is an insulator? Now, out of 5 electrons in the valence band, if one can go to the conduction band, what is it?
Semiconductor.
Semiconductor. If 2 can go to the conduction band,
Semiconductor.
semiconductor. If 3 can go to the conduction band,
Semiconductor.
if 4 can go to the conduction band,
Semiconductor.
if all 5 can go to the conduction band.
Conductor.
Now, did you understand the difference between conductor, semiconductor, and insulator? If all can go, conductor. If nothing can go, insulator. If some can go, semiconductor. Now, let me give you an example with respect to your exam. If your exam is 100 marks, if you get 0, you are insulator. If you get 100, you are conductor. Any marks between 1 to 99, you are semiconductor. Because any marks between 0 to 100 is between minimum and maximum. That means semiconductor. Let me repeat. If you get 0, you are insulator. If you get 100, you are conductor. Any marks in between, you are a semiconductor. That means even if you get 2 marks, you are a semiconductor. Even if you get 98 marks, you are a semiconductor. Understood? 0 is insulator, 100 is conductor. Anything between 0 and 100 is semiconductor. Now I have given you notes about semiconductors, and I have told you what is 1 electron volt in terms of joules. 1 electron volt is 1.6 into 10 power minus 19 joules. Now study all of that. I will give you 2 to 3 minutes. Then I'll ask you questions based on this. Whatever I have done. Okay, very easy.
99.99 then
What?
Semiconductor.
Come again.
Sir, if it is 99.99, then also it is a semiconductor.
Yes, actually in real life it is a conductor, because in real life there is nothing called 100%, but hypothetically, theoretically, it is a semiconductor. Even 0.0001 is a semiconductor. Even 99.999 is a semiconductor. I hope you understood. Theoretically.
Yes, miss. Oh, okay, sir.
So how much time will you need to revise today's only semiconductors notes, not magnetism? Study only the semiconductor notes that I have given. I'll give you 2 to 3 minutes, then I'll ask you questions. then I'll go to the next topic. Remember, semiconductor is the easiest chapter in your 11th standard. Don't complicate it. It's very easy. Okay. So read, I'll give you 2 to 3 minutes and then I'll start with your Viva. Okay. And I want all of you to switch on your cam in the next 2 to 3 minutes so that I can ask you the question. Okay. Now you can switch off your cam and study. In 2 to 3 minutes, you can switch on your cam and be ready to answer. Now you can switch off your cam. Okay, now switch on your cam. We'll start with the Viva. If you don't know, it's fine, no problem. You can answer how much ever you know. Okay, it's something like strict that you have to answer. It is just how much you remember. Okay, so let me. So we'll start with Rohit.
Yeah, yes, sir.
Rohit, tell me, what is a conductor according to you? Any definition. I've given you 2 definitions of conductor. Give me any one definition of conductor.
Conductors are the solids in which the energy gap between the valence band and conduction band is 0 volt.
Very good definition. Right? Perfect, good. Soumya,
Yes, sir.
define semiconductor.
Semiconductors are the solids in which the energy gap between the valence band and the conduction band is less than 3 electron volt.
Very good. Aditya,
Yes, sir.
define insulator.
Insulators are the solids in which the energy gap between valence band and conduction band is more than 3 electron volt.
Very good. Correct answer, Aditya. Darshan.
Yes, sir.
Darshan, tell me, what is the energy gap of a conductor, what is energy gap of a semiconductor, and what is energy gap of an insulator?
For conductor, it is 0 electron volt. For semiconductor, it is less than 3 electron volt. For insulator, it is more than 3 electron volt.
Okay. Pashwa.
Yes, sir.
Give me 2 examples of conductors.
Conductors, metals, metal,
Give me 2 examples, I said. Give me 2 examples of metals then.
metals, iron, aluminum,
Iron and
aluminum. Copper.
Ruchit.
Yes, sir.
Ruchit, give me 2 examples of insulators.
Insulator. Rubber. Rubber and glass.
Rubber and
Hello.
glass. Okay, that is good. Rubber and glass. Okay, very good. Rohit, Jigar.
Yes, sir.
Give me 2 examples of semiconductor.
Semiconductors, liquid or solvent.
What? Ecuador. Ecuador is a
Liquid.
country.
Liquid.
Liquid. So which liquid?
Water, alcohol.
Water. I'll tell you one thing. Our entire chapter is based on solid. Okay. In fact, our chapter starts with solids are classified into
Yes,
3
sir.
categories. Then
Uh,
you're telling me milk, water, honey, all that. We are not making breakfast here, correct? Give me proper example of semiconductor. જીગર ભૂખ લાગી છે સુઈ જાવું છે શું કરવું છે બોલો
no, sir. Can I tell for insulator?
શું થયું સવારના પોરમાં ફિઝિક્સ મંડે સવારના ફિઝિક્સ ઓ માય ગોડ I am going to uninstall Zoom on Monday.
No, sir,
Correct.
because when you were teaching semiconductors, I went to washroom, that's why.
Oh my god, that is why all liquids are coming. Okay, I will ask other person, then you come back. I'll come back to you, Jigar. Okay, I will go to Rutvik.
Yes, sir.
Okay, very good. I like the name. Very similar to Ritvis. Have you heard of Ritvis, Rutvik?
Yes, sir.
Yes, very good. So Rutvik, tell me 2 examples of semiconductor.
Germanium and silicon.
Germanium and silicon. Okay, very good. Abdullah.
Yes, sir.
Abdullah, tell me, if an electron is in valence band, is it free or is it not free?
Not free.
Not free. Okay, very good. When will it be free then, Abdullah? Electron in valence band is not free, correct? Answer is correct. My question is, when will it be free then?
Sir, can I tell this? I know.
Okay, tell it.
Sir, because the electrons will be free when it goes to a conduction band. When
Okay,
it is
very
out
good.
of the structure of the atom.
Okay, correct. Abdullah,
Yes, sir.
can you define what is a conductor?
Conductors are solid in which energy gap between valency bond conduction bonds is zero energy valency.
What? Oh my god. Solids, conductors, listen to me carefully. Conductors are solids in which energy gap between valence band, not bond, valence band and conduction band is 0 electron volt. Okay. Okay. Now let me ask. Let me ask Sujal. We'll wait for 5 seconds for Sujal. Sujal 5. Sujal 4. Sujal 3. Sujal 2. Sujal 1. Sujal is not answering, so Sujal will have to go to the waiting room. 1 minute. Okay, let me put Sujal in. Okay. Manasvi. Manasvi 5. Manasvi 4.
Yes, sir.
Yes, where is your camera? Okay, answer without camera. Okay, tell me, what is an insulator, Manasvi?
Insulator have no free electrons due to which no electricity can be conducted.
Okay, fair enough. Even this is the definition of an insulator, no problem. Okay, I think the people who are always answering, I've asked all of you. Others can keep your cam off and enjoy, no problem at all. And yeah, Sujal is not even aware that person is in waiting. That is good. Now, we studied what is conductor, we studied what is insulator, we studied what is semiconductor. Correct? All of you, we studied these three. Now, look at the screen. We studied what is conductor, we studied what is semiconductor, and we studied what is insulator. Conductor, semiconductor, and insulator we studied. Now going forward,
Sir, are semiconductors semi-solids?
They are not semi-solids, they are complete solids, but their conductivity is semi, means they don't conduct 100%. Got it? Got it? They are 100% solids, but their conductivity is not as much as that of a conductor. Correct? For example, is weak student half of a bright student physically? No. Even weak student and bright student both look the same. But can I say the mental capacity of a weak student will not be as that much of a bright student? But physically, can I say weak student and bright student look the same? They look the same. Only the mental capacity is different. Like that, I cannot say weak student will look only half of a bright student. Physically, semiconductors also look like conductors in the sense they are also pure solids. Okay, they are solids. They are not like semi-solids or they are not like soft solids. Okay, they are also solids, but the conductivity is changing. Is it clear? Okay, now we did conductors, we did semiconductors, we did insulators. Now going forward, I will not study conductor and I will not study insulator. I will not study. You know why? Because the chapter's name is semiconductor. So I will only concentrate on semiconductors. Therefore, going forward in my chapter, I will no longer study conductor and I will no longer study insulator. I will only study semiconductor. Is it clear? Going forward in my chapter, I will only study semiconductor. Now, in semiconductor, I have two types of semiconductor. In semiconductor, I have two types of semiconductor. One semiconductor is called as intrinsic semiconductor. Don't write anything. I'll give you the notes. And one semiconductor is called as extrinsic semiconductor. One semiconductor is called intrinsic. Another type of semiconductor is called extrinsic. Now listen to me carefully. If I ask you how many types of solids are there based on conductivity, you will tell me there are three types of solids. Which are the three types of solids? One is conductor, one is semiconductor, and one is insulator. Now I don't have to study conductor and I don't have to study insulator. I just have to study what is semiconductor. Now, if I ask you how many types of semiconductors are there, if I ask you how many types of semiconductors are there, you will tell me that there are two types of semiconductor. One is intrinsic semiconductor and one is extrinsic semiconductor. There are two types of semiconductor. One is intrinsic semiconductor and one is extrinsic semiconductor. Now, what is the meaning of intrinsic? What is the meaning of extrinsic? All that I will tell you. Okay. So listen to me. Write down side heading, types of semiconductors. Write down side heading, types of semiconductors. Based on purity. Look at the screen. Look at the screen. Types of semiconductors based on purity. Now, which are the two types of semiconductors? First one is intrinsic semiconductors and the second one is called extrinsic semiconductors. First one is called intrinsic semiconductors and the second one is called extrinsic semiconductors. Make a note. First one is intrinsic, second one is extrinsic. First one is intrinsic, second one is extrinsic semiconductors. First one is intrinsic semiconductor. Second one is extrinsic semiconductor. Okay. Now listen to me. Listen. First type of semiconductor is called intrinsic. Second type of semiconductor is called as extrinsic. Now, what is the difference between intrinsic and extrinsic? Listen to me. Intrinsic means what is naturally occurring in nature, that is called intrinsic. What is naturally occurring in nature, that is called intrinsic. And what is made by man based on that is extrinsic. For example, listen. Tree is available naturally. In nature, tree is there naturally. That is intrinsic. Now, if I take a tree, if I cut it, if I polish it, I'll make a table. Can I say table is extrinsic? Can I say table is extrinsic? Therefore, what is the difference between intrinsic and extrinsic? Is intrinsic is naturally occurring pure semiconductor. But if I take that, and if I make some changes to it, and if I add something to it, that it is called extrinsic. I'll give you one more example. You know, cotton plant is naturally there in nature. Now I take cotton plant, from there I remove it and I make a cotton shirt. Therefore, can I say cotton shirt is extrinsic, but cotton is intrinsic? Similarly, can I say silk also? Very good answer, Shreya. Silk is intrinsic, silkworm. But from there, if I make silk clothes, it is extrinsic. Milk is intrinsic. Ice cream is extrinsic. Milk is naturally available. If I make ice cream out of milk, that is extrinsic. Can you give me more example of something that is intrinsic and extrinsic? Stone also, correct. Stone is intrinsic. If I make some murti out of stone, then can I say that becomes extrinsic? Leather is intrinsic. Very good answer. Leather means crocodile skin, camel skin. All these are intrinsic. If I can make a wallet out of it, it becomes extrinsic. Aditya is saying gold, correct. Gold is intrinsic. If I make ornaments out of gold, it becomes extrinsic. Can you give me more examples of intrinsic and extrinsic? Paper, very good answer. Rice, very good answer. Paper is intrinsic. Soumya, paper, the papyrus tree is intrinsic. From there, if you make paper, it is extrinsic. Rohit is saying wheat, marble, rice. Correct. Very good answer. Diamond, tree to book. Oh my God. Excellent answers. Very good. Okay. I hope everyone understood what is the difference between intrinsic and extrinsic. Ruby. Okay. Now, can I say all extrinsic semiconductors were once intrinsic? Means I cannot make extrinsic without intrinsic. Means I cannot make gold ornament without gold. I cannot make milkshake without milk. Therefore, can I say if I want to make extrinsic, I will need intrinsic? If I want to make something extrinsic, I will need intrinsic first. That means I cannot make furniture without tree. Correct. Furniture is extrinsic, but how did I get extrinsic? From intrinsic only. Therefore, intrinsic means naturally occurring is called intrinsic, pure. If I add something to it, then it becomes extrinsic. Clear? Now, if you look at the definition of intrinsic semiconductor, look at the screen. What is the definition of intrinsic semiconductor? Check. Extremely pure semiconductor is called intrinsic semiconductor, means which is found in nature. Example is pure germanium and pure silicon. Now listen to me. If I ask you, give me the example of semiconductor. If I ask you, give me the example of semiconductor, you will tell me germanium and silicon are the example of semiconductor. If I ask you, give me an example of intrinsic semiconductor, then your answer will be pure germanium and pure silicon are my examples of intrinsic semiconductor. Therefore, what did you write down in your notebook? There are two types of semiconductors, intrinsic and extrinsic. Below that, write down side heading intrinsic semiconductor. Write down side heading intrinsic semiconductor. Write down the side heading intrinsic semiconductor. And write down what is written on the screen. Extremely pure semiconductor is called intrinsic semiconductor. Extremely pure semiconductor is called intrinsic semiconductor. Example will be pure silicon and pure germanium. Example will be pure silicon and pure germanium. Okay. So again, I'll repeat. There are three types of solids: conductor, semiconductor, insulator. Out of which you're only studying semiconductor. In semiconductor, yes, Shreya, it can be an example. Now in semiconductor, I have two types of semiconductor. Which are the two types of semiconductor? Intrinsic and extrinsic semiconductor. What is intrinsic semiconductor? Extremely pure semiconductor which are found in nature. It is called as intrinsic semiconductor. Example, pure germanium and pure silicon. Now, what is extrinsic semiconductor? This is the last definition for today. Now listen. What is extrinsic semiconductor? Now look at the screen. Please look at the screen. I will take one intrinsic semiconductor. I will take one intrinsic semiconductor. Okay. On that, I will put some impurity. I will put some impurity. Now, listen to me carefully. Impurity does not mean put kachra. Kachra does not mean impurity. Impurity means, for example, if I have a gold chain, anything that I put in the gold chain other than gold is impurity. For example, if I put diamond in gold chain, diamond is impurity. Anything you add which is not the same thing is impurity. For example, if I take germanium, okay, pure germanium, anything I add to germanium other than germanium is impurity for germanium, correct? So for example, if I add salt to water, tell me what is the impurity? Can I say salt is impurity? Because anything that I add to water that is not water is impurity. Okay, no, don't think impurity is kachra. Kachra is not impurity. Impurity is something that you add which is not that thing. Therefore, if I add an impurity, you know what is an impurity called in physics? Impurity is called as dopant. If I add anything into an intrinsic semiconductor, what is it called? Dopant. The process of adding a dopant to an intrinsic semiconductor is called doping. Not the doping that you are thinking. This doping is different. And finally, the semiconductor becomes doped semiconductor. Finally, the semiconductor becomes doped semiconductor. Now listen, I take an intrinsic semiconductor. Now please look at me. I take a pure piece of germanium. Okay, for example, look at this. I take a pure piece of germanium. What did I take? I took a pure piece of germanium. On that, I added little bit of phosphorus. Listen to me carefully. What did I take? I took an intrinsic semiconductor. Means I took pure germanium. On that, I put little bit of phosphorus. Now tell me, what is my impurity in this case? What is phosphorus? Can I say phosphorus is called dopant? Can I say phosphorus is called dopant? And the process of adding phosphorus is called doping. The process of adding phosphorus is called doping. And finally, now my germanium is not pure germanium. Now my germanium is germanium plus phosphorus. Now this is called as doped semiconductor. This is called as doped semiconductor or extrinsic semiconductor. This is called as doped semiconductor or extrinsic semiconductor. Let me repeat. What do I take first? I take up intrinsic semiconductor, means pure semiconductor. Then I add some impurity. What is the name of the impurity? Dopant. The name of the impurity is dopant. Therefore, I add dopant into the semiconductor. What is that process called? Process of adding dopant into the semiconductor is called doping. And finally, the semiconductor will become doped semiconductor. Finally, the semiconductor will become doped semiconductor. Is it clear? Now look at the definition which is on the screen. Look at the definition which is on the screen. Look at this. Extrinsic semiconductors, please look at the screen. Extrinsic semiconductors, the process of adding impurity to pure semiconductors is called doping, and the impurity atoms are called dopants, and doped semiconductors are called extrinsic semiconductors. An example will be doped germanium and doped silicon. Understood the definition of extrinsic semiconductors? Okay.
Yes,
Therefore,
sir.
write down this definition of extrinsic semiconductor. Shut it. Write down this definition of extrinsic semiconductor. Finished writing? Let me know if you have finished writing. Seconds more to complete this. Now let me repeat. There are two types of semiconductors. One is intrinsic semiconductor and one is extrinsic semiconductor. Okay. There are two types of semiconductors. One is intrinsic and one is extrinsic. Intrinsic means pure semiconductors. What is example? Pure germanium, pure silicon. Therefore, if I ask you what is the example of a semiconductor, you will tell me germanium and silicon. Now, if I ask you what is an example of intrinsic semiconductor, you will tell me pure germanium, pure silicon. If I ask you what is an example of extrinsic semiconductor, you will tell me doped germanium and doped silicon. You will tell me doped germanium and doped silicon. Is it clear? Now, what is intrinsic semiconductor? Pure semiconductor, which is found in nature, is called as intrinsic semiconductor. What is extrinsic semiconductor? If doped semiconductor are called extrinsic semiconductor. Doped semiconductor are called as extrinsic semiconductor. Doped semiconductor means process of adding impurity is called doping. The semiconductor will become doped semiconductor and the impurity is called dopant. Correct? Now I want all of you to revise this topic. Types of semiconductors. Then I'll ask you questions based on this topic. I want you to revise this topic, types of semiconductors. Then I'll ask you questions based on this topic. Start revising. Okay, done. Okay, so I'll ask just one or two of you, then we will stop. Okay, anyone wants to go for it?
Yes, sir.
Okay, Rohit, tell me, what is the definition of intrinsic semiconductor?
Semiconductor.
What is the definition of intrinsic semiconductor?
Extremely pure semiconductors are called as intrinsic semiconductors.
Jigar,
Yes, sir.
tell me, give me an example, give me two examples of intrinsic semiconductors and give me two examples of extrinsic semiconductors.
Intrinsic semiconductors is pure silicon and pure germanium, and extrinsic semiconductor is doped silicon and doped germanium.
Okay, very good. Soumya,
Yes, sir.
can you define what is extrinsic semiconductor?
Yes, sir.
Tell me.
When an impurity is added to the intrinsic semiconductors, this process is called doping, and the Atoms of the impurity are called dopants, and the doped semiconductor is called an extrinsic semiconductor.
Okay, Akshat. Akshat,
Yes, sir.
Akshat, tell me what is the
Yes, sir.
definition of intrinsic semiconductor?
The process of adding impurity to the pure semiconductors is called doping.
I'm asking you what is the definition
Impurity
of
atom.
intrinsic semiconductor, Akshat, not extrinsic.
Extremely pure conductors are called intrinsic semiconductors.
Okay. So with that, 1 minute, we will stop this for this class.